Hey guys, so this is the final graphing parabolas worksheet that I want to give you. We'll be doing some more later, but this is just one final practice page here. And I didn't even make this worksheet. It's from a different teacher, but we're going to use it as extra practice. They give you this equation. They give you the formula for the x of the vertex. You need the y. Right here, this is the way the teacher does an XY table. It's kind of weird. Vertex, you put that here. But I would like you to think of all the possibilities or all the details you could state about this parabola once you graph it. Like I have it right here on the side. I would like you to state all the things we've been stating. So find the vertex, obviously. State the axis symmetry, which is simply the x equals the x value of your vertex. The domain is x equals all real numbers. The range is y. It's going to be either greater than or equal to or less than or equal to the y value of your vertex. And also your y-intercept, you set x equal to 0 and solve. And for the x-intercepts, once you graph it, you'll be able to see where it crosses. And I might as well throw this out there right now. Tomorrow, we're going to be doing the x-intercepts by algebraically. Now, what do I mean by that? For the y-intercept, you set x equal to 0. For the x-intercepts, you set y equal to 0 and solve. So let me just give you a little taste of what we're going to be doing tomorrow. So if I told you find the y-intercept, where it crosses the y-axis, what would you do? For the y-intercept, you would set x equal to 0. So here are my x's. I would set them equal to 0, and my y-intercept would equal 0 because everything becomes 0. So I already know that my parabola, whatever it may be, it's going to cross the y-axis at 0. Now, if I asked you, what are the x-intercept values? The x-intercept values. Then you would set y equal to 0, and that would bring up this equation, 0 equals x squared minus 2x. And that's a quadratic equation that we used to solve 2 weeks ago, right? How do we solve this? We would factor, split, and solve. So I would factor out whatever I can from that binomial, and that would be an x. And if you pull out an x, what would you have left? An x minus 2, correct? Now that is equal to 0. And we're not used to seeing the 0 on the left side. If you want, you could put the equals 0 on the right side. And what you would have to do is, after factoring, you'd split it and solve. So you'd have this x could be 0, or the x minus 2 could also be 0. That's the zero product property. When you have something times something and it equals 0, the first something could be 0 or the second something could be 0. So you set up those two simple equations and solve them, but the first one's already done for you, x equals 0, and the second one's going to be x equals positive 2. So what I've done here is, and this is just a little taste of what we're going to be doing tomorrow. You don't have to do this right now. Okay, you don't have to do this right now. But tomorrow I'm going to be asking you to find the x-intercepts or to solve certain quadratic equations by graphing. And that's just saying that once you graph your parabola, your x-intercept values will be the solution to the equation. So right here, visually on the graph, I already know that it's going to cross at x equals 0 and also at x equals 2. So I already know it's going to cross at those two locations just by finding the x-intercept values algebraically. Once again, to find the x-intercept values, I set y equal to 0. And I solve. How do I do that? By factoring, splitting, and solving. To find the y-intercept, you set x equal to 0, which becomes 0. So in this case, the y-intercept is the same as the x-intercept. But you don't have to do the x-intercepts algebraically. You could just graph it the way we have been doing with the vertex formula and then plugging in values with an XY table. So let's do that on this question number 1. So for my vertex, negative b, actually let's do it right here. They already have the fraction set up. Negative parenthesis over 2 times parenthesis. What's the b value? The b is negative 2, so let's put a negative 2 right in there. What's the a value? 1. Okay, so the minus minus up on top changes to plus plus. We end up with a positive 2 over positive 2, which equals 1. And ladies and gentlemen, that is the x value of the vertex, 1. Okay, we still need the y value. How do we do that? We simply plug it back into the original quadratic equation. So let's plug it in. It already has the y equals right here, so you could start plugging in. Instead of x squared, we put parentheses squared. Instead of minus 2x, we put minus 2 parentheses. And we plug in that 1 value, and we do the math. 1 squared is 1, and 2 times 1 is 2. So you really have 1 take away 2. 1 take away 2 is negative 1. So the y value of the vertex is negative 1. So if we go to that vertex value of 1 on the x, negative 1 on the y, we end up right there. And as you could see, the x-intercepts that we found algebraically are perfect for this parabola with the vertex at 1, negative 1. Now from here, you could use an xy table, or because the a value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. So if you're going to use a pattern 1, 1, 2, 4, 3, let me write it right here. 1, 1, comma, 2, 4, comma, 3, 9. And that's only because the a value is 1. If you had a 2 right here, you'd have to modify your second numbers on that pattern. So right here, we're going to go 1 over 1 up. That's how we got to that point. Go back to the vertex. Go 2 over 1, 2, 3, 4 up right there. So let's put a dot right there. Let me put it in blue, sorry. And then go back to the vertex and go 3 over 1, 2, 3, 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 right on the edge. And of course, we're going to map those 2 blue dots over and across the axis of symmetry. As a matter of fact, I totally forgot about the axis of symmetry. That should have been step 2. After graphing the vertex, I need to draw that axis of symmetry right through it. And let's reflect those blue dots over to the other side. And we have our perfect parabola right there. So let's state everything that we can. So in addition to graphing this correctly, let's state everything that we can. We already have the vertex. It's right here. How about the domain? What do we put? X equals what? All real numbers. That is because the parabola does go to the left forever and to the right forever. How about the range? The range are the y values. So I want to say y, but I can't say equals. It's either greater than or equal to or less than or equal to. And that all depends if the parabola is above, opening up, or below a certain value. So what is this going to be? Greater than or equal to or less than or equal to? Greater than or equal to, because the parabola is opening up. And it's greater than or equal to the y value of your vertex. What do I mean by that? You see, the y value is right here. This is a y-axis. Here's a y value of 0, y value of negative 1, y value of negative 2. As you can see, this vertex has a y value of negative 1, and the parabola is above the y value of negative 1. Here's negative 1. The parabola is above. All right? So how could I say that the y values of the parabola are above negative 1? Y is greater than or equal to negative 1. So we have our domain. We have our range. We have our vertex. How about y-intercept? How could I find my y-intercept? You set x equal to 0 and solve. Or you could just look at the graph and tell me where it crosses. Where does it cross? The y-axis?
Negative 1. 0.
0. Right? So you can say y-intercept 0, or you could give it as a coordinate 0, 0. Right? Did you need the actual graph to find the y-intercept?
No.
No. You could have done it algebraically. How do you find the y-intercept? You set x equal to 0 and solve. All this would be 0, so your y-intercept is 0. That's why it crosses the y-axis at 0. How about the x-intercepts? X-int. Now, you could do it algebraically. Set y equal to 0 and solve. We already did that. If you already graphed it, you don't have to do that. You could just look and see that it crosses right here at 0 and right here at 2. So the x-intercept values are 0 and 2. The only other thing we could state is the axis of symmetry equation. That vertical line right through the vertex that cuts the parabola perfectly in half. That equation is what? Anybody? X equals 1. X equals the x value of your vertex. That's about all you could state, right? Now, we don't actually have this list right here, but those are all the things you do need to be thinking of. Now, one more thing. If you're looking at x-intercepts and it doesn't happen to cross at nice values, then give an approximation, right? Give a decimal or a fraction, right? So if it happens to cross right here in the middle, you would say negative 1.5 for the x value, right? For the x-intercept value, if it crosses in the middle. Just give a decimal approximation. And that's about it. You guys can handle this, or should I do one more? One more? Okay, let's do the one right below it, number 3. So my vertex formula, x equals negative b. They put the negative right here. I don't like putting the negative right there. I like putting the negative up there with the b value. So maybe we want to scratch that negative out. Negative b over 2 times a. So let's go negative parenthesis over 2 times parenthesis. We know the b value is 4, the a value is negative 1. So the b value is 4, the a value is negative 1. So you really have a negative 4 over a negative 2, and that's really positive 2. So the vertex x value is positive 2. So down here where it says v equals, I'd put a 2 where the x belongs. Now I still need the y, so I'm going to rewrite this equation. Negative x squared plus 4x minus 2. Notice that I put parentheses instead of the x's. That's because I want to take the 2 that I got for x and put it right into those positions, those parentheses. Put a 2 right there and a 2 right there. Now let's do exponents first. 2 squared is 4 with the negative in front. That will be negative 4. And then 4 times 2 is 8. And then bring down that minus 2. And if you go from left to right, negative 4 plus 8, that is 4. And 4 minus 2, that is 2. Positive 2, that is. So the vertex is at 2, 2. So 2 on the x, 2 on the y. You end up right there. Second step on graphing a parabola is to draw your axis of symmetry right through that vertex. We might as well state the equation of that axis of symmetry. What is it? X equals 2. Perfect. All right. Simply x equals the x value of your vertex, which is 2. All right, so we need more points. What could I do?
1, 1, 2, 4, 3.
You could use the pattern 1, 1, 2, 4, 3, 9.
But don't you have to multiply the 4 to 2?
Now, yeah, we are on number 3, which the a value is negative 1. So the pattern is going to be the same, 1, 1, 2, 4, 3, 9. The only difference is that it's opening down, right? Remember that. If your a value is negative, it's going to open down. But the a value does provide how wide or how narrow it is. So the a value of 1 is going to be exactly the same. It's just opening down with that same pattern of 1 over 1 down. Let's put a dot right there. 1 over 1 down will be right here. Go back to the vertex. Go 2 over 1, 2, 3, 4 down. And put a dot right there. Whoops. And then finally go back to the vertex and go 3 over 1, 2, 3, 9 down, 2, 3, 4, 5, 6, 7, 8, 9. And with that axis of symmetry, we're simply going to map it over to the other side, right? 1 unit away, go 1 unit this way, put a dot right there. And then go to the next blue dot, 2 units away from that axis of symmetry, 2 units away. We'll put us right on that y-axis. And then 3 units away, will put us over here. Now, I hope you guys understand that these coordinates are x and y values. So for example, I know I'm kind of getting off topic here, but if I went 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6, 7, negative 7. So 5, negative 7 is a coordinate, 5, comma, negative 7. What that means, guys, is if I plug in my 5 for x, if I plug in the x value of 5 into the equation up here, when I do the math, the answer will be negative 7. So every coordinate on the parabola is simply an input and an output to the function, right? Anyways, let's go back to graphing this parabola. That's opening down. And let's state everything else that we need to. The domain, x equals all real numbers. The range, y is what? Less than or equal to the value of 2, which is the y value of your vertex. And how about y-intercept? I'm just going to do it up here. Y-int. Where does it cross the y-axis? You could visually see that, or you could algebraically do it, which would give you the c value of your standard form quadratic trinomial equation, right? Yeah, to find the y-intercept, you set x equal to 0, which means this will be your output, which is negative 2. So you could write it as a coordinate, 0, comma, -2, or you could just say y-intercept is -2. Either way, we know it crosses the y-axis right here at that yellow dot. Now for the x-intercepts, all right, for the x-intercepts, they're not clean points. They're not nice points, all right? So for now, let's just give a decimal approximation of where this location is. So what would you say? 0.5. Sure, that's great. Why not? So 0.5, and how about this guy over here? 1, 2, 3, 3.5, right? So 3.5. And since we're approximating, let's do this little squiggly equal sign on those, because we're just giving an approximation there. So you have the rest of this worksheet to do. And tomorrow, moving on. One final thing, guys. You might find yourself with too much stuff right here. So it might be a good idea to get a separate sheet of paper and just label it on your separate sheet of paper like number 3, and then label all the details, right? What's your vertex, and just write it. Axis of symmetry, write it, right? So, whoops. Like for example, the vertex was 2, 2. Just write it on the side. Axis of symmetry was x equals the x value of the vertex. The domain, we already know x equals all real numbers. The range, y is less than or equal to the y value of the vertex. The y-intercept is the c value, -2. The x-intercepts, we said, were those decimal approximations